Hi, welcome back. This is Professor Ridge and today's lesson 4.1, Inequalities and Applications. And so an inequality is any sentence containing the following symbols. So we got less than, greater than, less than or equal to, greater than or equal to, or not equal to. So basically those are all inequality symbols. Now of course the first two and the last one, those are strict inequalities, and then these two, the third one and fourth one, those are actually compound statements where it's an inequality with an equation, but we still classify them as inequalities. Okay, because it's less than or equal to. So it's kind of both. All right, so we can modify our statement for solutions. We know solutions are anything that makes a sentence true, so that's the same for an inequality. Any value of the variable that makes an inequality true is called the solution. Okay, so the solution set is the set of all the solutions to the statement, whether it's an inequality or equation. That's the same. Alright, so determine whether the given number is the solution to the inequality. Okay, so we'll look at number 12. 3x plus 1 is less than or equal to negative 5. So let's try negative 5. And it's just like with an equation, we plug it in and see if it's true or false, yes or no. So it's negative 15 plus 1, that's negative 14. Is that less than or equal to negative 5? The answer is yes. How about negative 2? So if we plug in negative 2, is negative 5 less than or equal to negative 5? And since we have the equal to part, negative 5 equals negative 5, that's a true statement. So yes, that's a solution. How about 0? Is 3 times 0 plus 1 less than or equal to negative 5? That's 0 plus 1, which is 1. Is that less than negative 5? No, it's not. Alright. So, pretty straightforward. Just plug it in, check, say yes or no if it's true or false. Okay, so let's talk about interval notation. So a lot of times when we talk about solving inequalities, there's more than one solution, so we need to find ways to represent the solution set. Okay, so one way is using interval notation, or we can use set builder notation, or we can make a graph. So those are the three typical ways we represent solution sets for inequalities. Alright, so let me give you an example of all three types. So for set builder notation, the graph, and interval notation. So we use the brace for set, the set of all x's such that x is less than 3. We know we're going to graph a number line. You're going to go wherever 3 is. There's two ways you can do it. You can put a solid dot there. That's the way I like to do it. An open dot. This book uses a parenthesis. So that's the other common way to do it. And then you shade to the left. In the interval notation, it's basically it's like reading the number line from left to right, and you're starting here at negative infinity, and you're stopping at 3. You can put parentheses like that. Now if I were to put x is greater than or equal to 3, the way that would be different is you're going to go to the number line where 3 is, and you're going to make a bracket there. We're going to the right, so that's called a closed that end is closed. And then we're going to go off to infinity. So again, you do the interval notation as you read from left to right. So you're going to start at 3, and then you're ending, well, you're not ever ending, so that's infinity. And infinity always gets a parenthesis. So if I wanted all the points, all the x's such that x was between 1 and 5, the graph would look like you go to 1, 5, you're going to put a bracket at 1, bracket at 5, and a shade in between. And the interval notation, you start at 1, go to 5, and they're brackets because the equal to's. Now if there's no equal to's, there would be parentheses, which can be confusing. See if I can squeeze this in here. So you would make a number line, you'd use parentheses. And this would be parentheses 1 to 5. Okay? Alright, so let's to solve inequalities. Okay, so to solve inequalities, solve just like equations using the golden rule. You know, what you do to one side, you do the other. With the one exception, if you multiply or divide, that's the key word, to both sides. If you multiply or divide both sides by a negative number, you must flip the inequality sign. Okay, so you must flip the inequality sign. And again, it's a negative number, both sides by a negative number. So for example, if I ask you to solve 3x plus 5 is less than 10, you're going to do just like an equation to get x by itself. You're going to subtract 5 from both sides. You get 3x is less than 5. Divide both sides by 3, and you get x is less than 5/3. And you're done. Okay? If I wanted to do, say, negative 2x plus 1 is less than 8, you're going to subtract 1. Negative 2x is less than 7. Divide by negative 2 on both sides to get x by itself, but then you flip the inequality sign. See, we're doing that exception there, dividing both sides by negative 2, so that flips the inequality sign. Alright, so other than that, everything's the same. And we want you to start writing your answers either in set notation, set builder notation, or using interval notation, or graph, or all three, depending on how the question asks you. So here the book's asking you to do all three. You're going to solve it, graph it, and then you're going to represent the solution set both ways, set builder and interval. So we're going to do all three for solution set, graph, set builder, and interval notation. Alright, so let's look at number 38. 2x plus, minus 5 is greater than or equal to 9. So I'm going to add 5 to both sides. So we get 2x is greater than or equal to 14. Divide both sides by 2. So x is greater than or equal to 7. Graph it. So we're going to make a number line. Now the graph's pretty easy. If you don't label where 0 is and scale it, just put where we start, 7. We're going to put a bracket. We're going to shade to the right. So we're going to, and the equal to's part, so we're going to use a bracket. Personally, I like to put a solid dot, but I'll go ahead and do it this way, the way the book's presenting it. Again, this is acceptable. You can put a solid dot and then shade to the right. And then just shade in the arrowhead to say you're going to infinity. Okay, the set builder notation would be the set of all x's such that x is greater than or equal to 7. And then the interval notation is your basically, if you look at the graph, you're reading from left to right. It starts at 7 with the bracket, and it never ends. It goes to positive infinity. And just remember, infinity and negative infinity always have parentheses, whether it's the equal to is in here or not. You can never get to infinity, so it's always going to be a parenthesis. Alright, let's look at 46 here. Our first step is we're going to multiply both sides by -5 to cancel that fraction. And then you got to remember, the exception to our golden rule is when you multiply both sides by a negative number, you have to flip this inequality. Then we're going to subtract 3. So negative x is greater than positive 7. And then to solve by negative, divide by -1. Now here again, we have to flip the inequality back. So in this one, we might have got lucky, and if we forgot to flip it, as long as we forgot to flip it both times, we would have been okay. But anyway, every time you multiply both sides by a negative number, or divide both sides by a negative number, you have to flip that inequality sign. Okay, here's the graph. We're going to go to -7. It's a parenthesis. And we're going to shade to the left. And then our interval notation, we want to do set builder, set of all x's such that x is less than -7. And then interval notation, and we're starting at -infinity, ending at -7. It's a parenthesis because there's no equal to. Alright, let's look at one of these little more difficult ones. How about number 63? Okay, so my first step would be to simplify the sides, just like in an equation. So I'm going to distribute this -4 in here. Okay, so I got 8 minus 12 plus 4x. And then I combine like terms in that parenthesis, or bracket. 8 minus 12 is -4. And so my kind of rule of thumb is I distribute as a last resort. So I look to see if I can simplify further. I can't. Now I'm going to distribute. So that's why I didn't distribute to begin with. You want to work inside first. Do everything you can and then distribute as your last resort. That'll be plus. And then combine like terms. 8 minus 2 is 10. So I had to do all that work to simplify the left side. Now I got to do the right side. So again, I'm going to look inside. In this parenthesis here, there's nothing to do. So I'm going to distribute the 2. So I'm just kind of ignoring all this other stuff. I'm going to work in here. That's going to be 8x plus 1. Okay, nothing else I can do in that bracket. So now I distribute the 8 in front of it. So that's 64x plus 8. Minus 50. Combine like terms. Now I'm here. So now let's see when I get all the x's on the same side. So that's 72x. I'm going to get rid of these numbers. So that's 52. Then I'm going to divide both sides by 72. So x, now if I'm reading from the x, I know that's a greater than or equal to symbol, but reading from the x, x is less than or equal to, and I just got to reduce that fraction. So let's see, divide by 2, that'd be 26 over 36. Divide by 2 again, 13 over 18. So 13/18. Now when I write this in set builder notation, the directions here, they ask you just to solve and write solution set with set builder notation and interval notation. And it doesn't say graph. But I just want to graph anyway. I want you to realize that when you graph, you got to read it from the x. So if you go to 13/18, wherever that is, it's between 0 and 1. But if you went to 13/18, you're going to actually shade to the left because you're reading from the x variable. And the equal to. So it's going to be like that. So our set builder, again, you want to, generally it's rule of thumb, you're going to write the x first, then the symbol. So if we flip it around, you're going to flip the inequality sign with it. And then the interval notation would be negative infinity to 13/18. There you go. Okay, and then the last thing in this section is they have find the domain for the function. Now note, if you have a radical function, this is a square root function, this has to be greater than or equal to 0. So for the domain, so on this question, they're asking you to find the domain. So if I look at number 66, f of x is equal to the square root of x plus 2. For square root functions to be defined, the radicand, the number inside, has to be greater than or equal to 0, and you just solve that. So you just take the radicand, the number under the square root, write greater than or equal to 0, and solve it, and that's your domain. So you can use, again, interval notation, you can use set builder notation. So the domain is set of all x's such that x is greater than or equal to negative 2, or you could write it using interval notation. You could say negative infinity to negative 2. Either way. Alright, so that concludes our lesson for section 4.1. Go to my math lab and complete the exercises there, and I'll see you next time.